Welcome back, MEFB 213-2013 Manufacturing Processes class. A very good evening to all of you. If you remember, we stopped last in cold working processes. So let me go through, have a quick review what is cold working. So if you remember, cold working is a plastic deformation of metals below their recrystallization temperature, and the deformation causes the metal to be shaped. So like I had explained to you in the last lecture, the cold work metal is not something that begins from an ingot. So if you remember, what is an ingot? It's just a metal chunk, yeah, a metal chunk. So it's very or quite impossible to shape a metal chunk to a finished product without metal cutting or without die casting or without melting it. So in room temperature, just transforming an ingot to a finished product without any machining process or melting process is impossible. So therefore, how does cold working work? Cold working is performed in room temperature, but normally cold working would be an extension of a hot working product. So if you remember clearly, in hot working, we did hot rolling, yeah? Hot rolling where you produced from an ingot to an intermediate shape to a final shape. So normally the final shape, may be it a bar or a pipe, is taken, and the bar or the pipe will undergo bending or extruding in room temperature. And when that happens, that is performed in room temperature, and you either use a bending machine or an extruder and extrude it or bend it. And we basically have been doing this repeatedly, yeah, in our daily lives, but not realizing that this is a cold working process. So when you're using a hot worked metal, you are assured that the metal has got good mechanical properties. Okay, the grain structure is well aligned. Therefore, you have very, very high mechanical properties, and therefore in room temperature, you go ahead and perform a bending process or an extruding process, and you get a good performance metal or product at the end. So a quick review, yeah, we went through this previously. So if you remember, I told you the effects of cold or the disadvantages of hot working, of cold working, sorry, is it needs a lot of energy, yeah, definitely, because it's performed in room temperature. Therefore, you need to use high powered machines to do the shaping process. Therefore, you need heavy equipment, yeah. And overworking of the material can cause the material to sometimes fracture. And as in hot working, if you remember, when you heat it up above recrystallization temperature, all the stresses within the grains start to release, and the metal is stress free, and at the same time the grains rearrange itself in an orderly manner, and you capture the material at above recrystallization temperature, and once you shape it, then you let it cool back to room temperature. But that does not happen in cold working. So if you remember, I told you cold working, the metal is forced to bend or extruded in room temperature. Therefore, there will be built up stresses remaining in the metal unless they are removed by heat treatment. In the last lecture, I showed you how the grains are distorted, yeah. So at the point of bend, at the point of extrusion, you'll find the grains are elongated, or at some point maybe even fractured, broken, yeah, because of the extreme force that is applied onto the metal to change its shape. And obviously, because there's no heating above recrystallization temperature, therefore there's no recovery of the grains or metal properties. However, it's a productive process. You can maintain close tolerances. What do I mean by close tolerances? If you remember, because normally in hot working, you heat it up above recrystallization temperature and you shape it. And when the material cools back, normally during the cooling process, that's when shrinkage or expansion of material happens. So there will be slight differences in the dimension due to shrinkage or material expansion. However, you would not face this problem in cold working, because cold working is performed in room temperature, and obviously you get a good surface finish. Okay, having said that, let's look at the processes or and examples of cold working. So first you have tube finishing. versus wire drawing. So what is tube finishing? Tube finishing is tube drawing or tube reducing. Okay, so if you look at the diagram here, you have a tube. Okay, so when I say a tube is normally a hollow tube, a hollow material with inner and outer diameter. So you have a tube. In room temperature, you want to extrude the tube. So assuming that initially the diameter of the tube is 5 centimeter, now you want to reduce it to 3 centimeter. So what happens is the internal diameter is going to remain the same. How do you maintain the internal diameter of the tube? You are going to add in a stationary mandrel. So if you see there, a stationary mandrel is put to make sure that the inner diameter does not change. What you are changing is the outer diameter. Then you put it through a draw bench. Okay, so you're going to subject it through a draw bench. So when you put it through a draw bench, the draw bench will already have the diameter that you are requesting. So this is your material. This is your start work, and you will already have your defined diameter. So now from 5 centimeter, you want to reduce it to 3 centimeter. So your draw bench will be of 3 centimeter diameter. You're going to pull it through your draw bench, and when you pull it through your draw bench, because the mandrel is supporting the inner diameter, therefore you do not need to worry about the change in inner diameter. Inner diameter will remain the same. What changes would be your diameter of the outer diameter. So there will be a reduction from 5 centimeter to 3 centimeter. And when that happens, the material will elongate. There will be an increase in length. Okay, so there will be a reduction in diameter and increase in length. So that is a tube finishing process. Under the same category, we have wire drawing. So this process is similar to tube drawing, except that the mandrel or inside the tube is eliminated, because now when you talk about wire is always a solid wire, a thick solid wire, yeah, and a thick solid wire is drawn in this case. So this is wire drawing, yeah. So you have the initial wire stock. You are going to put it through a draw bench or a draw die. It's the same technique or same method, except that now you do not need an inner or an outer you do not need a mandrel, because you don't have an inner diameter. You have a solid wire, a thick solid wire. So now, assuming that the initial diameter of the wire is 5 centimeter and you need to reduce it to 3 centimeter, so it's just a very simple process. You subject it through a draw die or a draw bench. So this is the initial diameter, 5 centimeter, and your draw bench is designed to accept 3 centimeter. So when you subject it or you force it through the draw die, it will be forced to conform to 3 centimeter. There will be a reduction as you pull the wire out. There will be a reduction in the diameter from 5 centimeter to 3 centimeter. And there will be an increase in the total length of the wire. So initially, if the wire was 30 centimeter long, now after subjecting it to a draw die, after the reduction of diameter, you'll find there'll be an increase in length. Maybe now it's going to be 40 centimeter. So there'll be a reduction in diameter accompanied by an increase in the length of the wire. So that is tube finishing and wire drawing. Okay, so we have another example of cold working process, metal spinning and shear spinning. So what is metal spinning and what is shear spinning? Yeah. So if you look at this, you have metal spinning. We call it a conventional spinning. And we have a shear spinning. So what's the difference with it? First of all, when you use a metal spinning and shear spinning, yeah, this is a metal spinning conventionally done. You are going to clamp the material and you're going to manually shape the sides. It's going to be like a bell shape, yeah? So you're going to manually use a roller tool to shape the sides so that it have equal diameters on both sides. So it's like a bell-shaped curve. Same thing for shear spinning. Okay, same thing for shear spinning. But now you're going to use, for shear spinning, you're going to use a mandrel, a chuck, okay, to do the bending process. But instead of using a manual roller tool, you're going to now use a automated roller to shape the edges. So you have more accuracy when dealing with shear spinning as compared to metal spinning. Let's look at metal spinning. So metal spinning is a cold working operation of shaping thin metal by pressing it against a form, a mandrel. So this is a mandrel, yeah. Like I mentioned to you, this is your mandrel. So this is your mandrel, okay. So you're going to press that metal sheet against your mandrel. Here also, this is your mandrel. For shear spinning, you're going to press the metal sheet against the mandrel. And in metal spinning, you're going to use a manual roller to shape the edges. Whereas in shear spinning, you're going to use an automated roller to shape the edges. So, a right rigid conventional hand spinning tool deforms and shapes the metal over the mandrel, and this process is accomplished on lathe machines and is limited to symmetrical parts. Okay, so the most very important point about metal spinning is the wall thickness will not change. Okay, the wall thickness will not change. So what are the advantages of metal spinning? The tool cost is lower because you're using a manual roller to shape the edges. Labor costs are higher, okay, because you're doing manually, so you need skilled people to handle the machine. However, because you're doing, especially shaping the edges is done manually, okay, and then you're going to clamp it up and then only perform the shaping process. So you find that the production rate is lesser, okay, because a lot of manual work is performed under metal spinning. So the production rate is lesser. And the labor costs are much higher because you need to use skilled people to run the equipment. The advantages, tool cost is lower, and because it's going to be manually and it's a very simple machine, and it has fast adaptation to new products. What are the examples of products produced by this process? You can product bells, light fixtures, yeah, that is in bell shape, yeah. Light fixtures, lampu-lampu kat rumah, yeah. Kitchenware like the cover that you use, you know, when you have your pots, you have a cover on top like a tudung saji, a metal cover to cover while you're cooking your curry or your meat or your food, yeah. Kettles, you know, the kettle handle. A kettle handle is in a bell shape, yeah. So the kettle handle is also produced under metal spinning. So same exact products are produced using shear spinning. Yeah, you can produce belts, light fixtures, kitchenware, but how does it differ from metal spinning? The same exact process, same exact outcome, except that now shear spinning is automated. When I say automated, instead of using a hand roller to shape the edges, now you're going to use a power-driven roller to shape the edges. The wall thickness is reduced at the end of the operation. I told you in metal spinning, the wall thickness remains the same, but now the wall thickness is reduced. Okay, so I just explained to you this diagram. Okay, I'll stop here for today. I will continue more on this cold working in the next lecture. Thank you very much.